All right, welcome back. This is the discussion for 4.2, which is on the natural exponential function, or that exponential function that uses e, right? So let's start with number 3. Number 3 tells us that we have a function f of x is e to the negative 3x. And we're asked to find a few values. I'll do a couple of them. Let's start with, say, f of 2. Well, f of 2 would be e to the negative 3 times 2, or e to the negative 6. Now, of course, e is that 2.7182818 yada yada blah blah ugly number. So you'll need a calculator in order to do this. And I need to take e to the negative 6. So plugging that into my calculator, I get 0, let me write it down here, 0.0024 7875, and it goes on and on and on. Right? The answer is looking for 3 decimal places. So that's 002. The next digit is not big enough to justify an increase. So that's 0.002 is my answer for that one. If I'm looking for, the next one here says pi over 2. F of pi over 2 would be, again, you can use your calculator to throw in pi, or you can just estimate it at 3. I would use as many decimal places as you can get. 3.14159 should be sufficient. So this is f of 3.14159 divided by 2. And I would have to plug this into a calculator anyway, because this is e to that. E to the negative 3 times whatever that number ends up being, this 1.55 something, whatever it is. I don't know, I don't care. 3.14159 over 2. Right? Figure out what that is, multiply it by negative 3, and then take e to it. Right? So this is e to the negative 3 times 3.14. Pi over 2 is roughly 1.5707963. Multiply that by negative 3, and I'll just take e to that. So I have somewhere around 0.008,983, and it goes on, yada yada yada. 3 decimal places is that 008, but the next digit's larger than 5, so this estimates to 0.009. And there's some other values, play with them, plug them in, but the rest of them aren't much different than this. All right. Let's look at number 6. Six says find the domain and the range of the function. The function is e to the x. Okay. But we know what e to the x looks like graphically. If it's just a simple e to the x, it's an exponential that comes asymptotically off of the x-axis from the left, goes through that point, 0, 1, and then just goes up exponentially. So something like that, right? So e to the x has a range of 0 to infinity, but since it never actually touches 0, that range is open on the left. And of course, infinity is always in parentheses, so my range is 0 to infinity. Simply because I cover all of the positive numbers, I go very, very close to 0, but I don't ever actually get there. So it's open parentheses 0 to infinity. The domain is everything, right? The x values, anything that I want I can put in there. So my domain is negative infinity to infinity, or all real numbers, is what that means, right? All right, so that's number 6. Number 7 is similar, except our function gets changed to x plus 5. So it's the same function, f of x equals e to the, but it's not just x, it's x plus 5 now. The only thing that does is take this graph and shove it to the left, right? So instead of being at 0, 1, it's now at negative 5, 1. Right, this just gets shoved to the left, everything is just moved to the left. And so it still asymptotically leaves that x-axis, but it just goes up and exponentially increases sooner than the other one. But you can see my domain is still everything, because if all of my x values are valid, shifting the x values to the left doesn't change anything. I can still go on forever in both directions, right? So my domain is still negative infinity to infinity. The range is still 0 to infinity because I still asymptotically approach that x-axis on the left, and I still go up to infinity on the right. So my domain and my range don't change for number 7. Well, let's back up just a little bit. Recall the graph for number 6 when we just had e to the x. And let's take a look at number 8, whose function is now e to the x minus 4, but that minus 4 is not in the exponent. It's down here in line with the e, right? So that doesn't shift left or right anymore, that shifts up and down. In fact, because it's negative, it's going to shift everything down by 4. So this point here that's at 1 goes down to 0, to negative 1 to negative 3, right? So I have this point here. This asymptote that I would normally have on the x-axis gets also shifted down to negative 4. So I'm now asymptotically leaving the line at y equals negative 4, but I go through that same exponential increase. Everything's just shifted down. Down by 4, down by 4, everything's down by 4, right? So you can see my domain is not going to change, because if all of my x values are covered, shifting stuff up and down doesn't affect my domain, but shifting stuff up and down in this case now does in fact affect my range, because I can go all the way down to numbers as close as I want to negative 4, not including negative 4 because I asymptotically approach it, and so my range now is not 0 to infinity, but it is now negative 4 to infinity, simply because I've shifted everything, including my asymptote, down by 4. And so that's our range, and again the domain is the same. All right. Hopefully that helped. I will see you guys next time.